Good morning. So today, me and my group, Salma, Ali, Omar, and Tamer, will be presenting our thesis final project, which is about improved endpoint detection and response, commonly known as EDR. Our project was under the supervision of Dr. Sherif El-Kassas and Dr. Moustafa Youssef. So we're going to start off with the table of contents. We're going to start off by giving an introduction about the growing importance of cybersecurity, followed by an overview of the EDR. Then we're going to describe our system, and we're going to give a demo of our system. Moving on to the business plan, and lastly, we're going to talk about the improvements. Starting with the introduction, it will be discussed by my colleague Tamer.
So as we've seen in the past decades, the internet has become more and more important to people's daily lives. And with that, securing devices on the internet becomes even more important. And as a ranking done by the World Economic Forum on the biggest risks to human life, they ranked cyber attacks and cybercrime in general as 5th in terms of likelihood and 7th in terms of impact on the daily lives of people. And as we've seen during the COVID-19 pandemic, the reliance on the internet has become even greater, especially for companies that are becoming partially dependent and in some cases fully dependent on the internet. And that led to a 600% rise in cyber crimes as reported by the United Nations. So the problem with that is that the traditional security measures have failed to address and adapt to the current situation, as seen by the massive rise in cyber crime and cyber attacks. So new systems are now entering the market and being developed, and among these are endpoint detection and response systems, EDRs. And now I'll hand over to my colleague Salma, who will give an overview of EDRs.
Okay, so basically the EDR, I'll be talking about what's an EDR and the EDR problems and our survey results. So to begin with, what's an EDR? It's a security tool that uses software agents on an endpoint to collect data and send these data to a central database. So then how it checks if it's malicious or not? It will compare the current endpoint to the preset detection rules to see if there's anything outside the norm. And then if it checks there's anything malicious, it will send to the IT security team to respond to the threat. Okay. Moving into the problems, so as EDRs are quite recent development, they have a lot of problems. So the first problem is that it's difficult to deploy software agents, which is a problem for a business who allows their employees to use personal computers. The second problem is that it's not easily be scalable up or down because it has fixed size and it cannot be customized for every user's need. And then it's very expensive because based on our research, we found out that it costs $40 per endpoint per month with a minimum of 5 endpoints, which will be in total $200 per month, where a small business cannot afford. Last but not least, it somehow sends false positives, which is basically a false alarm, as it doesn't detect the malicious activities or it detected too late. Finally, it uses up a large amount of endpoints resources. And now moving into our potential customer survey. So we first thought that we have to conduct a survey among our computer engineering students, and we got 30 responses to make sure that our solution is worth to solve. So we found out that 73.3% of people need the more secure system on their devices, and that 66.7% will be interested in an improved EDR. So therefore, our service will be beneficial for individuals and large business. And now Omar will talk about the system.
Okay, so the system is consisted of two different parts, the endpoint agent and the monitoring module. And we also implemented two extra parts, which are the URL and file scanning modules. As for the endpoint agent, its job is to generate event logs for each of the events on the endpoint and to upload them to the cloud. We generate these event logs by using the Windows Sysmon driver. It comes as standard with Windows. You just have to configure it. And when configuring it, we chose the configuration that would generate the most amount of event logs, which we thought would allow us to get the most accurate results. For the cloud platform, we chose Elasticsearch, which is a log aggregating cloud platform specialized in this matter, and it can allow us to query the logs that we generate. And to upload the logs, Elasticsearch has a module that can integrate with the Sysmon driver called WinLogBeat, and it basically automatically uploads the logs every couple of seconds to the Elastic Cloud platform. The job of the monitoring agent is to use the previously uploaded logs and to query them to see if anything malicious is happening. We do this querying using the detection rules written in the Sigma format. The Sigma format is an open source rule detection rule format for EDRs, and it allows us basically to use other rules that were created by other businesses as well as rules created by ourselves. And this allows us to get a better detection possibility. We first use the Sigma rules. We first have to have an updated version of the Sigma rules on our local device. And after we get that updated version, we have to configure it to the Elasticsearch format. We do this using a command line tool that's provided by the creators of the Sigma rules, and it iterates recursively throughout the directory of the Sigma rule format, and it converts it to the Elasticsearch format. And after that, we ask the user if they want to add alerts to the detection rules. These alerts basically allow the user to get an email if one of the detection rules has been triggered. And after we add the alerts to the detection rules, the user should then take the file and upload it to their Elastic Cloud account. And now my colleague Ali will talk about the URL and file scanning modules.
So other than the monitoring of endpoints, we decided to add two more features. The first is scanning of URL. The second is file scanning. Why did we pick these two specifically? It's because according to UpGuard, which is a well-known cybersecurity vendor, 2 out of the top 8 threat vectors are mainly because of threats generated by malicious websites and malicious things coming from email attachments. Okay, so in scanning the URL, we decided to use VirusTotal. Simply get which is a famous cybersecurity vendor, that a company that is part of Google. They give us we take from them the API, and we just send the URL and they tell us whether it's malicious or not. So we allow the user to enter the URL, a single URL, in a text box input, and we respond to him by telling him if the URL is malicious or not. And if he wants to submit multiple URLs, he can just put them in a single file and put the file name in the input box, and it will generate for him a text file that contains the malicious URLs and which security vendor specify it as a malicious. In the file, on the other hand, the file scanning module, we do the same. We take the API from VirusTotal, and we use a hash of the file in order to make it more faster. Using SHA-1 hash, and just like you in the URL scanning, if the user wants to scan a single file, he just put the file name in the box and scan it. It will tell him whether it is malicious or not, and it would generate a report telling which cybersecurity vendor classify it as malicious. If he wants multiple files, then it's also the same. He will write the name of the files in a text file and just submit it, and it will generate a report stating which file in the text file is malicious and which cybersecurity vendor classify it as malicious. Now my colleague Salma will continue.
Okay, so I'll be talking about the value proposition canvas. It's basically a framework to make sure that our service meet the customer's needs and values. So first of all, the job to be done is basically a platform that monitors endpoints offline and online, and to analyze the data and send back to the user if anything is malicious. So the pains that a user can have before using our service is that he or she keep installing multiple antiviruses and keep changing the passwords into more complex one, and the fear of using public Wi-Fi and constantly backing up their devices. So our pain reliever is to create a platform that incorporates antivirus and some endpoints functionality to make sure that the system is more secure, and the improvements we have done to overcome the already existing EDR's problems. So moving into the gains, which will be a nice to have for a customer, is to make an easy platform to use and include multiple levels of severity, and keep the user updated if anything malicious happen. So our gain generators are to implement an easy platform to use, and always upload the logs and checks it using the Sigma rules, and keep the user also updated, and our extra added features of the URL scanner and the file scanner. And now the demo by Donia.
So now I'm gonna walk you through our systems demo. We're gonna start off with the rule generation demo. Then we're gonna give you a sample of the generated alerts we get on mail, or the user will get on mail. Then we're gonna give the URL scanning demo module, and finally the file scanning demo module.
Hello, today I'm going to walk you through our system. So we'll first test the rule generation module. We first click on the generate rules button. Then we're presented with this screen in which we can choose at which level of severity we should start to receive alerts if there are any. So I'll choose the medium severity level. And this means that the user will get the alerts for rules with medium, high, or critical severity levels. Now enter the email I want to get the alerts on. I'll confirm that this is the email. Now the rules are generated, and this is the file we get. Now to upload the file, we're going to open the Elastic Cloud, and we're going to go to the Manage tab under the Security section. We're going to choose Rules, and then we're going to choose Import Rules, and we're going to select the file we just got. And now, as you can see, all the Sigma rules are imported to the cloud.
Now we're going to give you a sample of the generated alerts we got on the mail we just input.
So here's an example of the alerts email we get. And here we can see that the severity level is in the subject in the email, and it tells the user which rule has been violated and how many times it has been violated.
Now the URL scanning module.
So next we test the URL scanning module. We press the button scan URL. Then we start off by testing a single URL. So for instance, we're going to enter google.com and try scanning it. It has detected that the URL is safe and it's not malicious. Now, if we're going to test a known malicious website, and try scanning it. Now we now get notified that this URL is malicious. Next, we scan a list of multiple URLs. So we pass the name of the text file that contains the list of URLs. And try scanning it. So the file has been generated. And here it is. So now we can see that it has listed the only malicious URL, and it says which security vendors say that this URL is malicious.
Lastly, the file scanning module.
So lastly, we're going to test the file scanning module. First, we're going to press the button which says scan file. So first, we're going to test a single file. So if we enter the name of the text file that has the list of URLs, which is list of links, and try scanning it, we're going to get that this file is safe and not malicious. However, if we enter test1.php, which is a file containing code for the reverse shell malware, and try scanning it, we're going to get that it's malicious, and we're going to get a report. And in this report, it says what different security vendors think the file actually contains. Moving on, we can scan a list of multiple files. We pass the name of the text file that contains the list of files. And try scanning it. Now we got a message saying that the report has been generated. Here it is, and you can see that it has listed the only malicious file, and it says what different security vendors think this file contains.
So now we're gonna move on to the improvement that would be discussed with my colleague Tamer.
Okay, so now we'll go through the improvements of how our system can compete in the market and where it surpasses other EDRs on the market. So first off is in terms of how easy it is to deploy. Our system really, our endpoint agent really contains two main parts. The first is the Windows Sysmon driver, which is already installed and only needs to be activated. And the second part is the WinLogBeat software, which is very quick and easy to install. In total, to get the endpoint agent working on our PC for the thesis project, it took us no more than 15 minutes. And if you compare that with other EDRs on the market, for example, Synet's EDR, they say it takes around 2 hours to even more for it to be able to be deployed and working on a PC. Although we don't know the specific environment that they tested that in. Next up is how scalable it is. Our system is very scalable, and that mainly comes down to the fact that we use the Elastic Cloud platform, and that gives us the ability to decide how much storage we want to use, how much processing we need to use, and how many endpoints we want. So, for example, if we compare it to, for example, VMware's Carbon Black, it requires a minimum of 100 endpoints for the system to work. With our system, we can have it working with a single endpoint if the user wants to, with 5, with 10, with whatever number. It doesn't have a minimum number of endpoints, and that's much better for smaller scale businesses who want to be much more cost effective or make more sound financial decisions. That fits in directly with the next point of it being cheaper. So if we look, for example, at VMware's Carbon Black, it costs $53 per endpoint per year, with a minimum of 100 endpoints. So it would cost the business a minimum of $5,300 to have that system running with them. Unlike ours, which only requires an $80 subscription with Elasticsearch, with very minimal extra costs per endpoint. So it's a much better system for smaller, medium-sized businesses that do not need to spend that much on securing their systems. And next up is another improvement is in terms of performance. And that our system's EDR has greater detection capabilities. And that's because our system bases those detections on the rule set that's based on the Sigma rule format, which is open source, and and since it's open source, it's continuously updated and continuously improved, and it's used by multiple bid organizations. And we have tested that. And what we saw is that it was able to detect malicious activity within and send an alert within at most a few seconds. But what we would want to do moving ahead is try to find a better precision rate for our detection of malicious activity. Now I'll hand over to my colleague Donia, who will discuss the improvements made in resource usage.
So the last improvement we made was that our system uses fewer endpoint resources. We tested the RAM speed on our endpoint, and we found that we tested the RAM speed for our endpoints, and we found that our endpoint agent had slowed down the endpoint memory operations by 7.8%, while on the other hand, a study was found that VMware's Carbon Black EDR has slowed down the memory by 40%. Moving on to the network usage. So to measure the network usage, we tested the network speed using a speed tester. So we had one PC with an endpoint agent and another PC without an endpoint agent. Both were on the same network via an Ethernet cable, and the PC with the endpoint agent had a download speed of 2.3%, slower than the one without the endpoint agent. However, both had the same ping time. So we concluded from that the PC with the endpoint agent is a little bit slower than the PC without the endpoint agent, but it was still good enough. Moving on to our systems blue ocean strategy discussed by Salma.
Okay, so based on our improvements, we were able to capture our service into a blue ocean strategy, which is creating a new demand away from our competitor. So this is obvious on the graph that we were able to create a new market away from our Carbon Black competitor, as our service is easy to deploy and easy to be scaled up or down, and the price is much cheaper, and it's easily getting up to date because of the Sigma rules. And it uses small amounts of endpoints resources, and finally it can be used by individuals and large businesses also. And this is our references.
We would like to dedicate our project to Dr. Sherif El-Kassas. He was our advisor who passed away this semester. He was very kind. He answered our question with open heart. And he taught us a lot, and he was our mentor. I'd like to thank Dr. Moustafa Youssef, advisor, and helped us very much during our thesis. Thank you. Any questions?